You're welcome back from break. Let's continue from where we stopped the other time. Let's look into example 5. Find the mean deviation of the distribution below. We have the table. To find the mean deviation here, let's quickly set our table in order. Class interval is this. Then frequency follows. After that, because our class interval is not the direct representative of x value, so we have to moderate it. So we have midpoint value, which represents our x. After that, fx, then quickly x minus x bar in absolute term, because it is mean deviation. So this is all we need to quickly fill up. Our 1 minus 3, 4 to 6, rather 7 to 9. Frequency is 2, 3, and 2. Yes, midpoint value, I have explained this to you when we were considering mean under groups data. So, you find the mean of this class interval 1 to 3, and the mean is going to be 2. So, that will represent our midpoint. Find the mean of this next class interval 4 to 6. That means 4 plus 6 is 10, divided by 2, that is 5. The mean of this class interval 7 to 9 is also 7 plus 9, which is 16, divided by 2, 8. This will represent our x value for operation. Now, fx means frequency times x value. 2 times 2, 4. 3 times 5, 15. 2 times 8, 16. So, addition of that is 35, because we will need it. Addition of the frequency is 7. Now, let's calculate our deviation. Deviation is x value minus calculated mean value. Therefore, let's know our calculated mean. Calculated mean is summation fx over summation f. Here, our summation fx is 35. Summation f is 7. So our mean is 5. To now calculate deviation. Deviation is x value minus calculated mean value. X value here is 2. Calculated mean value is 5. What the difference between them is 3. If you want to write 2 minus 5 to be minus 3, it will no longer be absolute. Here we must deal with absolute value. Just the difference between them without putting negative sign. The difference between 5 and 5 is 0. Subtract 5 from 5, that's 0. The difference between 8 and 5 is 3. So addition of that deviation column is 6. That's what we have to find. But we have frequency column. So we will not use it just like this. We will now create frequency into x minus x bar. That is frequency times deviation. Your frequency is this. Deviation is 3. That is 6. Do you understand? Frequency is 3 here, times deviation 0 is 0. Frequency is 2 here, times deviation 3 is 6. Addition of this is 12. Therefore, mean deviation equals summation f into x minus x bar divided by summation f. Mean deviation is summation f into x minus x bar, which is 12. This summation is 12. Summation f is 7. We have 7. 7 in 12 is 1. It remains 5. Put 0 at the back of the 5. It forms imaginary 50. 7 in 50, that is 7. It will remain just 1. If you put 0 at the back of the 1, it forms imaginary 10. 7 in the 10 is 1. It will continue like that. But if you look into the options, you see that the options are left in 1 decimal place. So round this to 1 decimal place, it will be approximately equal to 1.7. Therefore, the correct option here is option C. Option C, 1.7. Let's consider example 6. This example 6 borders on variance and standard deviation. Now, let me succinctly give you the relationship between standard deviation and variance. Standard deviation is equal to square root of variance. Don't forget this. If that is true, then this question says if the variance of this, and this is 4, the variance is already given. And the mean is 5. That is irrelevant. Find the standard deviation. What matters in all this is the variance you have been given and the standard deviation that you have to find. And you know that standard deviation is equal to square root of variance. And variance is given to be what? 4. Look at this very well. Put it inside the square root. Therefore, what is square root of 4? 2. That's just it. All the algebraic values and the numeric values put together here are just to confuse you. You just must understand the relationship between standard deviation and variance, and that is what you need to tap into here. So the correct option is option D. Let's consider example 7. Now I need to give you the formulae for variance and standard deviation. Variance for a non-tabulated data like this, variance is summation x minus x bar square divided by n, where n represents the number of items, the count of the numbers there. This sigma means addition, summation of x minus x bar square, that is the square of the deviation. X minus x bar is deviation. Square of the deviation divided by the number of the items we have there is the variance. Now, once you know variance, standard deviation of the same item is square root of this variance. Summation x minus x bar all square over n. This is standard deviation. Do you understand? That works anywhere. There's another formula for variance. If you care to use it, variance of such non-tabulated data could be summation x square over n minus x bar, the square of the calculated mean. This is variance. It works. The standard deviation of the same data that you can use this for will be square root of this, of summation x square divided by n minus the square of calculated mean. That is it. But if you have a tabulated data in the table that will have frequency, instead of this formula that we have here, you will say your variance will be for this summation f will be included. Summation of frequency times x minus x bar all square divided by summation f. Look at the way I write it, because this is with this, while the summation is just at the back. For standard deviation of the same thing, standard deviation, we have square root of this variance of summation f into x minus x bar all square divided by summation f. These are the formulas that you can make use of. But from experience, when you have non-tabulated data, even tabulated data, this type is easier. All of them are easy anyway, but this will be straightforward. And don't confuse them together. Now, let's consider this example 7 we want to do. Let's form our own table. X value first will be 1, 2, 3, 4, 5. Those are our x value. We need x minus x bar. The reason we don't put this inside absolute symbol, the slash, that means absoluteness, is that we are not calculating mean deviation here. So it's a passage. This mean deviation column is just a passage. So we move from there to the square of this. This is the deviation column. We square it, the square of that deviation, and that is the variance column. This is deviation column. This is variance column. And variance column is the last column when we are to calculate standard deviation, because you just sum it up and find the square root of it. That's why standard deviation is the square root of variance. So 1. What is our mean? The first thing to do is, I almost forget, mean, which is our calculated mean. Calculated mean equals, summation x over n in this case. Why not fx? Because we don't have frequency. Is non-tabulated data. So which is 5 plus 4 plus 3 plus 2 plus 1. That is 15. Am I right? Yes, 15. Divided by n. N is 1, 2, 3, 4, 5. 5. 15 divided by 5 is 3. The calculated mean is 3. If it is 3, x value is 1 minus the calculated mean 3. The difference is minus 2. Here, whether you use absolute value or the real value, it will not matter at all, because the squaring of it will negate, we cancel the negativity. So to say, 2 minus 3 is minus 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. So squaring it now under variance column. When you square negative 2, it gives you positive 4. Squaring negative 1, you have positive 1, 0, 1, 4. Addition now is 10. Therefore, standard deviation is square root of variance. Don't forget. Meanwhile, our variance column is here, which is 10 divided by 1, 2, 3, 4, 5. Divided by 5. Answer is square root of 2. Maybe you don't like the way I do it. Let me do it like this. Or standard deviation equals summation x minus x bar all square divided by n. Don't forget, the summation x minus x bar square is here, which is 10. Put it there. N is the number of items we have here. 1, 2, 3, 4, 5. 5. Square root of this. Square root of this. Square root of 2. So the correct option is option A. If you look at it, whether you do it like this, straight way, or like this, the square root of 2 is the answer, which is option A.